Nth term test for convergence and divergence. Number one, if the summation n goes from 0 to infinity of an converges, then the limit as n approaches to infinity, an is equals to 0. What that means? So let's open up this series. A0 to infinity. So we start from A0 and then we go to A1, A2, A3. We are adding them and then we will reach to the nth term and then keep on adding and then reach to the infinity. So what they are saying is they asked you, hey, let's take a look at this term. So when n is approaching to infinity, including the infinity and the terms before that, if they are equals to 0, so that means when n is large, we are adding up a bunch of zeros. So therefore, the sum equals to a real number. Therefore, the series converges. So just like what I said, the value of an are very small as n approaches to infinity. So if you write out the entire line, we are looking at these terms when n is very large. When n is very large, if these numbers are so close to 0, so that means if you look all the way to the right hand side, we are just adding up a bunch of value that is so close to 0, so that is not going to make the sum really big, and then therefore we say the series converges, and then the sum is only determined by the first couple terms. And then number two, if the limit is not equal to 0, then the series diverges. So that means these values, they are not equal to 0. I should write some explanation right there. So this one, as n approaches to infinity, the values of an are not close to 0. So not close to 0. So for example, so let's say you have numbers like 8, 7, 5, and 4, something like that. So you are adding them up when n is very large, plus you have a bunch of numbers before you reach there. So that means in this case, the sum is equals to infinity, and therefore the series diverges. So let's take a look at a series. So we have a summation, and then n equals to 1 to infinity, 2 to the nth power divided by n squared. So this one we will take the limit as n approaches to infinity, 2 to the nth power divided by n squared. So this is like just finding a limit. You plug in n, and then you will see that we have an infinity divided by infinity. So therefore, that trigger a L'Hopital's rule. So L'Hopital's rule. L'Hopital's rule. So for L'Hopital's rule, you have to write an h above the equal. That means we apply L'Hopital's rule right now. Limit as n approaches to infinity, and then you need to take the derivative of the numerator. The numerator is an exponential term that is 2 to the n, and then multiply ln the base. So if the base is e, then you have e to the n times ln e. ln e is equals to 1. The denominator is a power rule. We take the 2 down, and then n raised to 2 minus 1, which is the first power. All right, and then this one, okay, let's just make a note in here. So this one, I took the derivative of the top, that is equals to 2 to the n times ln2. I took the derivative of n squared, that is equals to 2n. This is not a quotient rule. Most people often think that L'Hopital's rule, you have a fraction, you have a quotient rule. No, you have a numerator over a denominator. You need to take the derivative of the numerator and then take the derivative of the denominator. That's all. Do we still have infinity over infinity? Yeah, we still have infinity over infinity. That means we will need to apply the L'Hopital's rule again. So that is limit as n approaches to infinity. And then the 2 to the n, so that will be 2 to the n. And then times ln2 again, plus we already have an ln2 from the previous L'Hopital's rule. And then the derivative of 2 times n, that is equals to 2. Okay, let's take the constant outside. So we have ln2 raised to the second power, and then divided by 2, and then limit n approaches to infinity, 2 to the n power, and then 2 to the n power, and then we have we have a constant. Then let's just copy the constant one more time. So this line, I am not applying L'Hopital's rule, therefore there is no h above the equal. And then you have 2 to the infinity. So 2 to the infinity, and then this is just equals to infinity. Infinity times a constant. Therefore, when n approaches to infinity, those terms are very, very large. Okay, how about this? How about this? We open this up, and then we have a summation. N equals to 1 to infinity. You have 2 to the n divided by n squared. That is equals to 2 to the first to the second power, and then plus 2 to the second, 2 to the second, and then plus 2 to the third, and then third square, plus 2 to the fourth, and then fourth square, and then fourth square. And then you will keep on adding until you reach to 2 to the something big divided by this big base raised to the second power, and then eventually you will reach to 2 to the 6,000 power divided by 6,000 raised to square, and then you will still keep on adding. And then do you see that when n is large, so these terms, the sum is enough to make an infinity. We don't even need to look at the first couple terms. Therefore, the sum is equals to infinity, and therefore this series diverges. The sum is equals to infinity. All right, so that is a L'Hopital's rule. Let's look at the next series. The next series, how about we have a summation? N equals to 1 to infinity. I have n plus 2 divided by 3n minus 1. This one, what is a really good way to do it? This one returns to the lesson you study, the limit lesson that you study before you study derivative. For this type of problem, I will look at the highest degree in the denominator. Okay, denominator. The highest degree is 1. Therefore, I will divide each term by the variable raised to the first power. Variable, actually no, that is not right. 1 over variable raised to the first, top and bottom. And then this is equals to, you know what, maybe not there. I need to do a limit first. Okay, let's do a limit. Okay, I will just do a limit. As n approaches to infinity, n plus 2 divided by 3n plus 1. The highest degree in the denominator is 1, then therefore I need to divide each term by the variable raised to the first power. And then this is a limit as n approaches to infinity, and then you have a n plus 2, right? So the top you have divided by n divided by n, and then the denominator you have 3n plus 1, and then you have to divide each term by n. What is that equal to? That is equals to limit as n approaches to infinity. I have 1 plus 2 over n divided by 3 plus 1 over n. When n approaches to infinity, this is 1 plus 0, 3 plus 0, and then that is equals to 1/3. That is equals to 1/3. So that means as n approaches to infinity, n approaches to infinity, those terms are very close to 1/3. You know what? I should say this. Not n approaches to infinity. How about this? I will just bring this down and then just start plugging in numbers. 1 plus 2 divided by 3 times 1 minus 1 plus 2 plus 2 divided by 3 times 2 minus 1 plus 3 plus 2 divided by 3 times 3 minus 1, and then you keep on going, right? As n becomes very large, you are just adding up a bunch of 1/3. As n is getting very large. As n is getting very large. That means we have a converge because the limit, okay, this time we are not having an infinity. Okay, hold on. Wait a minute. Hold on. Okay, this one, you have the sum of n copies or many copies of 1/3. So therefore, the sum is still large. The sum is still large according to what we have when the limit is not equal to 0. This time we have a sum, which is not a sum. This time we have a 1/3. 1/3 is not equal to 0. So I am sorry, 1/3 is not equal to 0. So the sum is still very large. So we still say the series diverges. Okay, we still say the series diverges. Let's take a look at one more. How about this one, summation? N equals to 1 to infinity. I have 3 divided by n and then n plus 6. So this one is limit as n approaches to infinity. We have 3. Can we distribute the n? N squared plus 6n. And then what is the highest degree in the denominator? It's a 2. Then I will go ahead, divide each term by n squared. N squared. So therefore, you have limit as n approaches to infinity. The top, you have 3 divided by n squared. The bottom, n squared divided by n squared plus 6n divided by n squared. When you take this action, that means you want to divide each term by n squared. And then that is equals to limit as n approaches to infinity. You have a 3 over n squared. And then this is a 1 plus 6 over n. When n goes to infinity, 3 divided by infinity is 0. 6 divided by infinity is 0. And then this one is equals to 0. So finally, you have a limit equals to 0. And then according to here, to the nth term test for convergence and divergence, when the limit is equals to 0, which is written right there, we say the series converges. All right. So now I can say the series converges. Okay, so that is the nth term test. And then we have some example for divergence and then one example for converge. So that is the end of this video. If this is something that you would like to watch, you think my video is helpful, subscribe and like, and I will meet you all in the next video.